Hello, this is the section 7.5 lesson on the topic of percent increase and decrease. So in this section we're going to continue working with percents that we introduced in section 2.5, and the main tool that we're going to use in this section is strip diagrams. So we're going to solve every problem in this section with strip diagrams, and one thing I hope you learn from this lesson is that a lot of different types of problems can be solved with strip diagrams. So first let's refresh our memory on the meaning of a percent. So a percent is simply a fraction where the denominator is 100. So one example we did in section 2.5 was 10%. 10% as a fraction is 10 over 100, and then we could reduce that to 1/10. So let's draw a simple strip diagram of 10%. So these strip diagrams are going to be just like what we've drawn all semester long whenever we worked with fractions. So to draw a picture of 10%, that's equivalent to drawing a picture of 1/10, we start off with a hole. And so in this case, our hole is going to be this long strip. And then we divide that hole up into 10 equal pieces. And so each one of these pieces is 1/10 of the whole, which is equal to 10% of the whole. So that's all there is to drawing a simple picture of 1/10. In this section we're going to use a lot of strip diagrams that look a lot like this. Another thing that we want to remind ourselves of is the meaning of multiplication. It's something we've been talking about all semester. We're going to use this meaning many times throughout this section. So meaning of multiplication is we take the number of groups times the number of items in a group, and that's going to equal the total number of items. So in all these problems we're going to be figuring out a number of groups and a number of items in a group in some way to get the total number of items. So let's take a look at our first example. There are two boxes of chocolate. The chocolate in the second box weighs 30% more than the chocolate in the first box. There are 6 more ounces in the second box than in the first. How much does the chocolate in the two boxes weigh together? There's kind of a lot going on here, and so to set this up, let's draw a strip diagram. So let's start off with box 1. We'll draw one long strip to represent the chocolate in that box, and then we're going to break this box up into 10 equal groups. Why 10 equal groups? Well, because we're talking about 30% here, and 30% is 3 times 10%. 10% is 1/10, so we're going to break this box up into groups of 10, or into 10 groups. And so each one of those groups there, each one of those boxes represents a group of chocolates. Now I'm not going to call it a piece of chocolate because that group there may be 2 or 3 or more pieces of chocolate. I don't know how many pieces of chocolate are in this box, but it represents a group of chocolate. Now we're told that our second box weighs 30% more than the first box. So in terms of my strip diagram, I'm going to draw a strip for box 2, which is the same length as box 1, but then I'm going to add 3 more groups to it. So we're going to add 30% more. So now let's analyze the strip diagram a little bit to try to figure out. We want to know what's the total weight in the boxes together. And so we're told that box 2 has 30% more, so that's represented by those 3 groups there. We're also told that that additional amount is equal to 6 ounces. So 3 groups of chocolate equals 6 ounces. And so now we're going to figure out how much one group weighs. And so we're going to divide both sides by 3, and we're going to get that one group equals 2 ounces. So now we know how much each group of chocolate weighs. Now we just need to figure out how many total groups of chocolate were there, and we'll take this times the number of ounces in each group, and we'll get our total amount. Well, in box 1 we had 10 groups of chocolate. In box 2 we have 13 groups, and so we have 23 groups total. And so if we take our 23 groups times our 2 ounces per group, we're going to get a 46 ounces total. And so there's our answer. So the basic steps that we did here is we drew our strip diagrams. We figured out how many ounces were in each one of those groups, took that number of ounces times the total number of groups, and that gave us our total weight of chocolate. So look at our second example. This is going to be a little different scenario, but we're still going to use strip diagrams and the same basic approach to solve this problem. So the sale price of a basketball is $12. That is 40% off the original price. What was the original price? So we're interested in the original price. So in our strip diagram, we're going to draw a strip representing the original price. So this long strip represents that original price. And we're going to break this up into 10 equal pieces. Why 10? Well, because we're talking about 40%, which is 4 times 10%. 10% is 1/10, so it makes sense to divide this up into 10 equal pieces. So here, one of these groups, or one of these boxes, represents 10% of the original price. So we could think of this box as representing a group of money. So this is the original price, but we're told something about the sale price. Sale price is 12, and that's 40% off the original. So if we X out 4 of these boxes here, what's left, these 6 groups, is going to be the sale price. So our sale price equals $12. So let's figure out how much money is in each one of those groups. So we're told that 6 groups here equals $12. So let's divide both sides by 6. And so one group is going to equal $2. So now we know how much money is in each one of those groups. And so we have a total of 10 groups in the sale price times $2 in each group. And so that equals $20. And that equals, so that's our original price. That's the original price. So there we go. The original price was $20. It's kind of the same basic strategy as what we did in the first example. Figure out how many items are in each one of those groups. Take that times the total number of groups, and we're all done. So before we do our third example, let's introduce another definition. A percent change is equal to the amount of change divided by the initial amount, and then we're going to take that times 100% to convert it over to a whole number. And so we start off with some initial amount. That's going to become our denominator, and the numerator is the amount of the change. And so let's illustrate this with our next example. There are 2 elementary schools in a county. After 10% of the children at the first school were moved to the second school, both schools had the same number of children. So the question is, by what percent did the number of children at the second school increase when the children from the first school were added? So there's a lot going on here. We've got 2 schools, and the first school was bigger because it said that we moved some of those children to the second school, and now they have the same number. So the question is, by what percent did the number of children at the second school increase? So let's draw a strip diagram to represent this. So let's start off with school 1. We're going to draw a big long strip there for school 1, and I'm going to break that up into 10 pieces, again because we're talking about 10%. And so each one of those boxes represents a group of students, which equals 10% of the students in school 1. So one long strip there for school 1. Then we're going to draw a smaller strip for school 2. Now at this point I'm not exactly sure how long to draw this. We'll kind of verify the length here in a bit, but we know that school 1 is bigger than school 2. So let's analyze this picture a little bit. We were told that 10% of the students from school 1 moved to school 2, that now they've got the same number of students. So what we're going to do is we're going to take one of these groups from school 1 and move it down here to school 2. Let's draw like that. We're going to cross off this box. And so now we're told that both schools have the same number of students. So our picture is going to look like this, where both strips are equal to the same length. And so we see that school 1 has 9 groups in it, and school 2 is also going to have 9 groups. And so that tells me that originally what we had in school 2 was 8 groups. Now we don't know how many students was in each one of those groups, but that's not what's important here. This problem was asking for what was the percent change in school 2. So the percent change is going to be equal to, remember the definition was the amount of change divided by the initial amount. Well, we just figured out that initially there were 8 groups of students, and the amount increased by 1 group. So 1 group of change divided by 8 groups originally, and then we take that times 100%. And then we just have to do that in arithmetic, and if we do 1 divided by 8, we know how to do that arithmetic, so we'll skip the details. This comes out to be about 13.3%. So school 2 increased by 13.3%. They went from 8 groups up to 9 groups. That's a change of 13.3%. Let's look at our fourth example. A class has 30% boys and 70% girls. If there are 8 more girls than boys, how many total students are in the class? So we're not asking for a percent change in this problem. This is going to be more like the first and second examples. The question is, how many total students are there in the class? So we're going to draw a strip diagram here to represent our class. So the long strip represents the entire class. We're going to break this up into 10 pieces. Why 10 pieces? Well, because we're talking about 30% and 70%. So here a box represents a group of students, which is 10% of the class. Now we're told that we had 30% boys, so that means we've got, like, these 3 groups here are boys, and then 70% girls, so that means that these 7 groups here represent the girls. Now notice that the girls have 4 more groups than do the boys. So let's kind of circle those 4 groups there. So those 4 groups there represent those 8 more girls than boys. And so we have that 4 groups equals 8 students. Specifically, they equal 8 girls, but 8 students. And so if we divide everything by 4, we get that 1 group is equal to 2 students. And now we know how many students was in each group. We originally had 10 groups, so let's take our original 10 groups times the 2 students per group, and that's going to give us 20 students total. And so there we go. There's our answer. Our class originally had 20 students. Let's look at our last example. This last example is going to be a little bit more complicated than the previous examples because we're going to have to deal with some fractions here, but don't let that scare you. Fractions are just numbers. We're going to treat them like any other number. So it says one school had 15% more children than another school. Now 15% is going to be a little bit different than we worked with before, because on all the problems we worked with before we dealt with multiples of 10%. 15% is like 10% plus another half of a 10%, so we'll have to take that into account. After 12 children moved from one school to the other, both schools had the same number of children. And then how many children were originally at each school? So let's kind of draw a strip diagram here. And let's start off with the second school. We're going to start off with the second school because we're told that the first school had 15% more children. So let's draw a strip here for school 2, divide that up into 10 pieces. So each one of those boxes represents a group of students, which again is 10% of the students at school 2. Now we're told that the first school had 15% more children. So let's draw a strip for school 1. And so school 1 is going to be the same length as school 2, but we're going to need to add 1.5 groups. So this additional 1.5 groups, that's 15% of the children in school 2. So we're not adding 2 whole groups here, we're adding 1.5 groups. So it's a little more complicated. So let's analyze the strip diagram a little bit more. We're told that 12 children moved from the first school to the second school. So that means we're going to have to take half of this additional group here and move that down here to the second school and add it so that now both schools have the same amount of children. But now the question is, well, just how big of a group is that? Well, we were told that we took half of that additional amount, so let's take half of that additional amount. Well, that additional amount was 1.5 groups, which as an improper fraction is 3 halves. So if we take 1/2 times 3 halves, we're going to get 3/4 of a group that moved from school 1 to school 2. Okay. So that's important. That tells us how many groups moved from one school to another. Now we're also told that 12 children moved from one group to another. So that 3/4 of a group is equal to 12 children, or 12 students. So let's figure out how many students is in each group. So let's divide both sides by 3/4, just like we've done before. Now don't let the fact that we're dividing by 3/4 scare you, because it's just a number. So one group is going to be 12 divided by 3/4, which is 12 times 4/3. We know how to divide by fractions. And so now we do this arithmetic. We can clean things up here a little bit. The 3 and the 12 will cancel off to 4. And so we have 4 times 4 is equal to 16 students. So one group equals 16 students. Now we need to figure out how many children were originally at each school. Let's clean things up here a little bit. We determined that one group equals 16 students. And so let's take school 2 to start off with. School 2 had 10 groups of students times the 16 students in each group. And so that's a total of 160 students. So that's how many were in school 2. Now school 1 contained the 10 groups that were in school 2 plus 1.5 groups. So school 1 has 11.5 groups. And let's convert that over to an improper fraction. 2 times 11 is 22 plus 1 is 23. So school 1 had 23 halves groups. And we'll take that times the 16 students in a group. So we'll simplify this, 1 and 8. So if we take 8 times 23, do that arithmetic, we're going to have 184 students. So there's our answer. School 1 had 184 students. School 2 had 160 students.